Oh, here's a picture of some of the earliest work on the flux capacitor principle from 2003, found on Testify archives. And I was then using just an ordinary water pitcher with a copper tube inserted inside. This stuff was all stolen. Okay, we found out that we've made a tremendous mistake here. And here's a diagram showing what this mistake involved. We had 1/7, we were actually 1/7 off resonant on one of the phases. We had a bad connection wire between the four capacities comprising the 3.5 microfarads. And what this did is it set the position of phase 1 on the drawing here back in time where it should be, and there should have been the correct position. So now that we've made the correction, we find that we no longer obtain in the empty unloaded state this flattened kind of triangle. We'll quickly let that go for now and go to the subject of the present video. And we also showed an effect where seemingly the magnetic field was coming out in time before the actual voltage to make it do so. This is also a mistake. This is attributable to scope operation on triggering levels, which gets to be a little bit beyond my knowledge. We're going to go ahead and try to read through this real quick. We understand that since Lenz law works as nature at 90-degree phase angles of cause versus effect, that in a three-phase system of air core coils, whereby manipulation between phasings themselves as mutual inductance factors are the exclusive agent governing the magnetic polar interactions, that now the currents existent on the coils themselves have two sources, both their line connections and the 90-degree Lenz law shown by the pre-existing currents as secondaries in closed-loop circuit readings prior to actual line connections. Since the three systems are themselves tuned for their proximity effect, we conclude that on the phasing rotation itself, the Lenz law voltage arrives in time before the actual line voltage, with the net effect that the vector addition of both EMFs show that the timing of the voltages appearing on the coils have been advanced. Notice that I crossed out retarded. Advanced in time. But this also means that since the Lenz law component arrives as a peak signal 30 degrees before the actual line signal, its effect on the resultant vector itself should be termed retarded. How wonderful then it is to engineer the system in a manner so that the reverse situation occurs, and we can also claim terminology-wise that we have instead advanced the timing between cause and effect. We won't go into that, but we will go into this, show what we're talking about. Because the extra influence acquired through the air by Lenz law interaction in tuned three-phase mutual induction resonance occurs before the voltage delivered by the actual line connections, this is initially considered as an advance in timing. However, in time established by the true positions in time of the source voltages, it has actually been retarded instead of advanced. So here we show phase 1, here we show phase 2 at 120 degrees, here we show phase 1, Lenz law effect on phase 2, and here we show the resultant vector sum of the line coupled and air core induction, and that vector sum retards the position of the phase rotation in time instead of advancing it. Okay, now that we've gone through that, we have to go through the hourglass, the clock question. I have a clock. This clock has an hour hand and it has a minute hand. I start at 12:01, and in 12 hours the hour hand traveling 12 times slower than the minute hand. Well, the minute hand is going to cross over the hour hand 12 times. What's the time period to do in between each of those points in time where those hands are simultaneous? It is not 1 hour. It is not 1 hour and 5 minutes, but that's a pretty close answer. We find that at 6:33, this has happened 6 times. At 6:33, the hour hand will be underneath the minute hand. Now what we have here is an interference effect. The interference effect is created by one rotation going faster than another rotation. What happens then when we advance the phasing rotation in time by this principle, that we find that the magnetic field isn't simply moved into the future, it keeps moving into the future till it meets itself again. It makes a full circle. Just like the minute hand on a clock makes a full circle before it meets the hour hand again. And we see in that analogy that for the first 6 times that it happened, it took over 6.5 hours, leaving only 5.5 hours for the remaining segments in time. So what we see then is that it is not symmetrically divided in half between when the hour hand is moving away from the 12 and when the hour hand is moving towards the 12. Now on this effect of achieving a faster phase rotation than what the line voltage rotation would normally achieve, we find that some of the times it's fighting the line voltage when it's completely opposite, and when it returns back to normal, it's aiding the line voltage. What we can account for is the fact that since this is not symmetrical, that we're going to have a longer time period when it's aiding the line voltage than when it's opposing the line voltage. Now what we've done here is we've put the scope on channel 2. We've added channel 1 and channel 2 so both effects can be seen. And we're going to hurry up there and run over there and turn the machine on. We're at 10 milliseconds per division. Now if that's visible, you should be able to see the first 4 sections of time. The phasing rotation is opposing the line rotation, and it's reduced the voltage. During the remaining time period, it's aiding the voltage, and it comes back up to where it was. It takes 1/10 of a second to do this, and that is precisely the amount of time that we see. Where's that thing at? That is precisely the amount of time we suppose is causing that neon to blink. Every time one full circle happens, at that point in the circle where it's opposing the line voltage, it causes the neon discharge to be reduced or go out. And I think that'll be it for this. We'll make a quick look at our conditions here. Once again, we have 25 volts being in excess of 10.4 and 3.6 as its vector causes.